Hey everybody, this is day 2 of trying to make a speech model that's noise sensitive in Claude code. Um, Yesterday we left off with kind of a semi-complete model in the code base, but there's a few problems. For one, the this model seemed to train, but it only worked on CPU. There's just CUDA installation problem, so I fixed that. It took about 20 minutes, and I needed to go into the true TTY terminal to fix the problem. It involved like reloading some NVIDIA modules. Anyway, that's fixed. And then looking over the code yesterday, I realized it did leave out some things. For example, the residual vector quantizer, which is a core part of the codec. So I had it just now. I asked to read the paper, look at the code base, figure out what's missing. And it looks like it did catch that, so I'm very happy about that. The other things seem a little less important. So I'm going to tell it to do this. Okay, please add the residual DQ and the, what is this? And we also want a causal model. So this, the causal model is whether or not you can you look at all of the input before you start producing the output. In the previous one, it would be causal at some point, but the convolutions weren't set up right, so they would read far into the future if you stack them this way. So we're having it do this now, and we'll see how that goes. Yeah, so also the training is proceeding. Let me just fix this. Every time I stream, I scale things down, so it looks kind of bad on the screen. I have to figure out how to do that better, because OBS, the streaming tool I'm using, it doesn't handle the 4K well. But yeah, so GPU is running and it actually trains much faster now, as you might expect. I think these are the losses, even though they're called vals. So that is cool. The thing we need to add is, oh yeah, so there is some kind of like learning schedule. We're using atoms, so we don't have to worry too much about the actual values. But what can we see? We can see that the losses are going down, so that is good. And yeah, we get about one step every, I don't know. I don't think this is right. We get about 3 steps a second. Maybe that is right. But yeah, things look more or less okay. The L2 loss will be very telling. It's not actually going down. And the L2 loss of 0.2, I'm not sure what that means. Anyway, we can try to hear some audio output. I'll just let it finish this quantizer. And then we'll look at it later to see if it makes sense. But I think it's okay. Let's look again what we have. So the way the quantizers should work, they should like be stacked, and one quantizer goes into the next, the residual goes into the next quantizer. So the first quantizer captures the lion's share of the information, and the next one does a little less, and so on. And the idea for a codec would be you can use a variable number of these. So if the information is very, if you want a higher quality, you can use all of the quantizers. Otherwise, you can select some smaller number. So this seems to be more or less a stack of some sort. So we have the vector quantizer class, and then the residual vector quantizer class is the actual stack. Right. Yeah, so this is reasonable. One thing about the actual vector quantizer class, we have to evict sometimes, like when there's a dead code, and I saw the word dead, so it's probably doing this. So vector quantizers, they just break up the multi-dimensional space into a fixed number of regions, and those just get translated to raw integers, and that's how we can code things, just by labeling. It's kind of like a paint by numbers like thing. You take a large space and you break it up into a lot of small cells. But yeah, there's code that looks like it will possibly do the right thing. It's important how these are initialized. Looks like we just randomly, we do random initialization, which is reasonable. So it should take just, that means it takes the first batch and then randomly initialize it. The only thing is we have to be using a large enough batch size. And this is across all the frames too. So this part I'm a little unsure about. We'll have to look closer at this. But I am reasonably impressed that it could actually get something resembling the vector quantizer, because the last time I asked it to do something like this, ChatGPT 4, I think, it really didn't do that well. And then the other part is these codes need to be updated over time, so they kind of float towards, you want to make sure the cells in the vector quantizer aren't that close. It kind of looks like it is doing that. The main risk for this, again, is make sure you have a large enough data set. And if it's doing this on the fly with our training batch, our small training batch, that's something we have to be careful about. But yeah, good. All right, it's still writing code. Yeah, okay. And I'll ask it to do a few more things. What do I want? For one, I want inference running. I want to run inference every, let's say, 250 steps. And have examples on TensorBoard, audio clips, input and output. Other thing I want is for loss summaries on TV to be better named is val a loss. Okay, and the other thing, okay. All right. Let's just give it this for now. Okay, so the other thing about the vector quantizer we really need is, so the vector quantizer just takes this continuous high dimensional space and translates it to just the integer that's saying which cell it's in. And then there's the opposite operation that takes the integer and blows it up back into the full dimensional space. Using, yeah, just a lookup table. But let's see how it is doing that. Is it actually doing that? Quantized. I mean, for the purpose of the training, as long as you're not doing speech coding, we don't actually care about that integer. But otherwise we do. And it looks like it is returning the indices. So the indices are they tell you which index, the cell index basically. So this actually looks okay. Yeah, so it's taking the argmin. This is a pretty standard way of finding the closest cell. And this is the actual compression here. There's the idea about adding noise to the input. But quantizing is also, in some sense, adding noise. Yeah, but I'd say this looks pretty reasonable. We'll see how it performs. So at some point we're going to benchmark against, say, regular soundstream or against a decoder from like Wave LM, Audio LM. Okay, so it says it's doing all this now. Okay, let's stop training. Let's start with a smaller batch size. Let's just 16 or so, not 8. Alright, so okay, just as a hard kill, I guess it's fine. Actually don't like that. I'd like it to do something else, but can't we just stop the process? I guess I can do it. Okay, no, it did it. Cool. All right. So it's going reasonably well. Training on batch 8. Let's see if my tensor board is still running. Alright, so this is now a clean tensor board, and it's running pretty quickly. What is the steps per second? Let's ask if it's committed recently. Okay, it's gonna give me some spectrograms apparently. Great. What was I gonna ask it for? There's one more feature I wanted. Oh yeah. I'd like to be able to run inference on a wave file. Can you also generate some wave files from the datasets? And give me a script and tell me how to run inference script. Alright, let's see where we're at. I think I need to reload. So we're at 1K, and I don't see any wave files. So let's check there. Yeah, but I'm really glad we got this 3090 up and running. It is being fully utilized. As you can see, we're pretty close. Earlier it was burning 400 watts and at 100, so I'm not sure why it's different now, but yeah. It's probably because I'm using this small batch size. Before it was using like 1.5 gigs, sorry, 15 gigs. Now it's using 3. So that's probably part of it. We have to figure out the optimal batch size. Possibly it can do this for us, but we'll see. Seems like the training is taking a long time. No, the training is running. I can see it. Maybe. So the inference stuff always is a little annoying because you have to like find the latest checkpoint. There's scripts for that, but let's see what it does. So it takes a model. Let's see. So for checkpoints, maybe it's not done writing it yet. Alright, but it's generated some waves. Ignore the generated. Let's see how we're doing in Git. Oh yeah, this is horrible. Let's give it this information. All artifacts in Git. All right, so a little slow on this part, and I still have no idea what this sounds like. Yeah, so this validation runs every 100 steps, it looks like, which is reasonable. I would call this eval, not validation. But cool. We're not. One thing we can say is our losses are sort of going down, but not dramatically. And part of it may be the small batch size is not useful. But the data is all pretty similar in this synthetic data set. We also haven't heard any of the data, so that will be something good to look at. Let's look at some of these wave files. Whoa. Okay, so that's not a this is total silence as far as I can tell. We can looks like the fine zoom selection doesn't really work on Linux. But we can see, yeah, there's silence here. All right, so this one obviously doesn't work, but what about the rests? Let's try this one. I mean, maybe high pass doesn't work. Let's try a band pass. 153 hertz. Okay, that works. With a little envelope. Yeah, good. The other thing we need to do is in the data segmentation, we want to be able to load a larger wave file and then like just pick out a chunk. So that's one thing, especially when we get to speech. Data loading should load a wave. I'm going to ignore that for now. Anyway, you usually have a step to process data. But anyway, let's see what it did. Okay. Great, now commit. It was saying, alright, you can run inference like this. Yeah, I'm not sure why it says unknown hertz. But yeah, let's see what other files are broken. How about, so anytime you have unknown hertz, I'm gonna guess it's just broken. Oh no. Alright, I'm gonna take a little break. Okay, so we're back. And let me see where we're at. I think I have to fix this. Okay. So yeah, we left off, I think, being able to train on GPU. Actually, can't remember exactly where we left. So let's just continue. So we have training working, but we can't really see what's going on in the tensor board. There's no audio samples. And I hit the limit. So let's just continue and see where we get. Yeah, so as we begin training, I'm going to open the tensor board. Let's see how this is looking. So what I really want to see is like audio samples here. I also asked it for an inference script, which might work. And I've been looking at the audio files in this sample waves directory. Let me resize this. Yeah, it's a little crazy with the scaling, I know, but I don't have a solution for that yet. Wow, it's like really like 10 times the size it should be. Okay, so I had to shrink this window down. All right, so some of I realized there's like pairs of 3 files. One is the metadata, and it's this kind of like, and they're all 2 seconds at 16 kilohertz, but the frequency and the filter type I think are arguments. Later we'll ask it for more complicated things and we'll throw speech into the mix, but for each file there's a noise and an input. So let's see, if we pass in the input, that's what the input looks like. And the noise used to generate it is this one. So that can be pure silence sometimes. The file might or might not have noise. So here's a very strange one. This looks like a 1 or a 0.5 hertz waveform or something with noise. I really don't know what happened here. So this is something maybe to look into, because this won't sound very good either. This is a large DC offset. Okay, but let's see where we're going. It should be training now. Yeah, it's training. And let's look at our tensor board. Alright, so we're at 1K steps and we have audio now, so that's good. We have input, noise source, and reconstructed. So these are probably just going to be total noise to begin with. Let's see. The input should be okay. There's no noise. Yeah, and that's kind of what you expect. That's at step 250, so... I see. So I'm not sure if there's different samples for each one. Let's see. No, it looks like it's the same. Okay, and that's actually good because we get to see how it progresses. So it started off like this, which is a bunch of beeps. There's at least tones in there, but it's not... I won't call that an improvement. Let's see, so this is at 1500. Okay. So that's not good, but let's look. We don't have like hyperparameters or configs yet set up. Parameter config files yet set up. Let me create some. There's various tools, and I'm trying to remember the names of the tools for the different hierarchical configs. Using a popular config library. Cascade inherits etc. So you want to set that up. Also, I'd like more than one file being evaluated every 250 steps. Alright, so let's have it do that. While it does that, I'm going to look at the VQ. I want to make sure there's enough. And I think that's going to come down to the trainer. It's probably just some default thing set up here, but I actually call train.py. And yeah, so there's a lot of arguments here. 128, so it's actually 7 bits. No, that's not. The bottleneck mention is not really its number of bits. I'm sorry. This there's nothing. This doesn't seem to be anything about the VQ codebook size. Let's see. So codebook size is passed in. And it's 1024, so there are 10 bits per codebook. Okay. And let's see. Yeah, I don't think that is I think we just use this default here, and that's actually, I think that's a reasonable default, so we can just leave that there. We do want a summary for codebook utilization. Let's just do the first third, because it gets too much if you have 10, I think. Yeah, so we're using this YAML. So it's using one called Hydra, which I haven't used. But I'm gonna guess and pick that one. That's a popular one in PyTorch, which I also don't normally use. Okay, let's see how this has been going. Do we have anything resembling that tone yet? It's a little better. There's like a tone that bounces around. Yeah. Yeah. And we also have these like inference scripts. And it looks like, yeah, you can pass in a file and you get out a file. So that is nice. So I may change this problem just to re-implement the encoder-decoder paradigm. And just do a regular training on speech. But I do want to see where this goes. So I'm not sure how long this project will take, but I'm willing to spend a few sessions on it. And then the other thing I want to work on is a speech quality model. And maybe use it to detect age. I think that'd be a cool, fun project. Yeah. Let's see where we're at. I mean, it's made progress from the noise that it started with. tone actually does go up now, right? No, it's one tone. Okay. But yeah, we'll see. Sounds like my training has also stopped. Yeah, let's have it try things out. So yeah, a few things we can say is it got the model generally right, but it did miss entire components. And we won't know that it actually implemented things right until we have like a nice sounding speech output, or at least the noise output if it can replicate that reasonably. But reviewing the code, it looks not bad. Let's see how it does the dead code stuff. So it's okay if a code is not used, but if it remains unused over many samples, and that's no good. Yeah, we'll have to see what happens. There's also the possibility we initialize the k-means or the clustering a little differently. But yeah, why don't we just see where we're at first? Let's have let's have a loss for that. It sound from the noise level of my computer, we're not training, so let's see what's going on. Yeah, so it seems one of the weak points is this the framework installation. It does okay sometimes, but often it's like uninstalling and reinstalling everything. And you can see it's struggling a bit. We also didn't get the spectrograms we were promised. I don't really care right now because I can tell these spectrograms are not going to be super interesting. So I think I'm fine with that. Let's see what it's been doing. Yeah, and like all these PYC files, it should be ignoring. Let's tell it that. It's really struggling with this, so I'm not super optimistic about spending a reasonable amount of time on that since this was not the bottleneck right now. There's one thing, it's hard to like restore the context from when before you like launched a new thread in Claude Code. I'm not sure there's a way to do that, but that would be a reasonable feature to have. But yeah, so I guess yesterday I renewed Claude Code. I did it because I was in the middle of the stream and it canceled. But yeah, I think I would have renewed it anyway. But I don't feel compelled to buy like the $100 plan. Yeah, and then the other thing I want to do maybe is update. So I have that website I made with, it was before Claude Code. This was December when everyone's using Cursor to like create this kind of like paper scanning website, pulls the latest papers. I just run it on a little MacBook Air that I installed Linux on. It like just feeds a fire hose of papers into, I think it's 0440 mini. So it's super cheap and actually finds interesting papers related to longevity. I'm thinking about replicating this for speech research and then maybe building a new project based on that. I mean, either for the synthesis problem, disentanglement, or for the speech quality problem, which is near and dear. And then maybe the nice intersection would be this like aging of speech. It's really unclear whether you can definitely hear when somebody's older. You can tell when somebody's over 60, for example. You can distinguish someone that's 60 and someone that's like 25, even though they're both adults. But it's a little unclear what exactly causes that, and if the causes are actually useful as a biomarker, or if they're just like a side effect that doesn't correspond to health at all. All right, looks like we are training again. And there's a lot more info this time. Let's see if it added more samples, because that would be nice. It did not. Well, actually, I'm not sure. Yeah, it did not, as far as I can tell, add more samples. Actually, there's a fly trying to get out. Let me just take care of that. Okay. All right, so it trains something. Please unify the train scripts and inference scripts. I want to keep track. Then tell me what to run. Start again. Actually, no. Stop. What I mean is one train script, one inference script, one gens. Ignore the generate sample script. The other thing we eventually need is ability to resume training. So that's just load from a checkpoint and resume. Let's just ask it if that's supported. Still hasn't fixed the Git repo. Alright, looks like that's kind of supported. This is a lot nicer. We can see what's going on at every step. And we can remove this later. But let's see if we see the audio yet. Yeah, we do. Okay, so I only see one file. And of course the resynthesis has nothing yet. But let's see how far we get. Sounds like it's clipping a little bit. Okay, let's try 750. There's a little bit of noise in the background. But yeah, it's not converging very fast. Let me see what the parameters were used to set this up. So batch size was 8, which is probably way too small. Let's adjust the defaults a little bit. So it should all be in the model. No. Down sample and up sample, we might change around a little bit. So would that be training? Yeah, so let's do 32. Might even be able to do like 48. Let's try that. These are just total guesses for now, and that's fine. And let's change the validation to every 250, every 200, 250, so I just want 3 samples. Yeah. It's a little hard to say anything interesting is happening here. We're only using half the memory, so we could up the batch size even more. I'm not sure if it's handling the full 2 seconds of audio or not. That's another thing to check. Probably don't even need to handle that much. But yeah, it's fully utilizing the GPU, so maybe this is fine. But yeah, let's see what that resulted in. So now there is another model. Well, it's the same sound. And yeah, it doesn't sound like anything special. But we'll wait till we hit the 500 mark and see if that changes the sound. But I think the combined recording time from these 2 sessions is now over an hour, so whatever we're at, I think I'll just Wrap up soon. Yes, we still don't hear any interesting audio. I mean, I would like to have more than these 3 samples. Is it possible these are in the like output or something? Oh, I'm in a different directory. Excuse me. So this one's called defer entropy. I guess it's 23. Alright, so this is just like this folder could be used for the build artifacts, but it's tracking what the config was, which is good. I didn't get it quite right for some reason. Okay, slash. Okay, so samples are here. It actually does have more samples. Oh no, it only has one wave file. Okay, so this is a problem we can ask it to fix. We ignore outputs. Also, there's still only one wave triplet. Not be there all the time. Make a README describing how to use the tools. So since we stop, I found it's easy to forget even the entry points and things like that. So this README ends up being more and more important. Make a Claude MD file. Explains to your future self context what you need to fix, etc. Yeah, but this model so far is pretty useless. There's probably some things, some serious things that need to be fixed. Let me see if we got our scalars for the codebook utilization. No, we just still don't have that. So, we also, oh, you know what? I don't know if we added the codebook losses at any point, and that's pretty important for the VQ. Yeah, so that might be a big problem. Let's ask it about that. When you read the paper, did you notice that there were codebook losses? And let me just make sure I have that. So I did see something about a commitment loss, but I'm not sure if that was actually used in the code. So that would be for entropy models quantizer, right? Commitment loss. Okay, so there is a commitment loss. And presumably that gets used, but I think that's not the only loss. So the commitment loss tries to get the encoder to output things closer to the center of the cell. But I think there's another one about like making sure the codebook's spaced correctly. Let's just quickly look at the paper. Feature matching loss, quantization loss, according to 10. Oh, I think this is not the soundstream paper. Okay, not this paper. That's a related paper though. Alright, well, that might be for another day. Like I said, I kind of want to wrap up now, but thanks for watching, and we'll see where this goes.